It's a while loop. We discussed while loop in where? In LabVIEW. While loop and for loop. Anybody remember the difference between while loops and for loop? What is the difference between the two? What we discussed in LabVIEW? Anyone? When do we use while loop and when do we use for loops? Because both of them are going to be discussed today, but we have discussed both of them when we were discussing LabVIEW. And you used both of them in LabVIEW.
For loop is like for a set amount of times, and while is while the expression is true.
That's true. Very good. So for loop runs for a set amount of time or set number of iterations that you set at the start of the while loop, for loop. And while loop is you do not know how long it's going to run. It all depends on this expression that you see is going to become true. As long as it is false, everything will keep on running, or vice versa. As long as it is true, everything keep on running. And when it becomes false, then things will stop. Now, both conditions were in your hand in LabVIEW, that either you can set while to run as long as the condition is not met, or you could run while loop as long as the condition is met. So both of them. In MATLAB, you can do only one thing, that as long as the condition is not met, everything is written in the while loop statement or operation that's going to run. As soon as the condition is met, then while loop, whatever is written in the while loop, basically the statement gets fulfilled and it's going to come out of the while loop and start executing whatever is outside the while loop. So this expression value needs to be 1 in order for the while loop to be fulfilled or to come out. As long as this expression value is 0, that is, it is false, everything that is written in the while loop, or maybe I'm doing it opposite. While this is not equal to that, actually, as long as the expression is correct, everything that is written is run, and then once the expression becomes false, it comes out. So so it's very simple. The syntax is very simple, as you can see. There's some examples I'm giving you, but I can just show you example quickly. Let's go and show an example for while loop. So let's say you are asking user to give you some number. Enter a number to calculate let's say y is equal to x squared. Let's say you want to calculate that. And while, let's say, while x is less than 100, let's say as long as x is less than 100, you're going to calculate that y is equal to x squared. And what you're going to do, you will update the value of x. Let's say you increase the value of x by 1. X is equal to x plus 1. Now, x is equal to x plus 1 is a very common way to write increment a value in most of the programming languages. You can write the same as, I believe, x equal plus 1 or x plus equal 1. One of them, I forgot what exactly. But usually I just use x is equal to x plus 1. But I think you can also write, I can check actually, x equal plus 1. That means that x is equal to x plus 1. So if it doesn't work, then we're going to go back to x is equal to x plus 1. And so in this program, I'm asking user to enter a value, what I'm calling x, and I'm checking if x value is less than 100. If it is less than 100, calculate y is equal to x squared, and then I'm going to print that value out. And then I'm going to go ahead and increase the value of x by 1, check it again if it is less than 1, again, keep on going. As long as it is less than 1, it will keep calculating the value of y. And as soon as the condition becomes false, then it's going to come out of the while loop, and we can print that. display value of x, or we can do printf, actually that's better. Printf value of x is greater or equal to 100. Oh, you can use display actually. If you don't have to print the value, then you can just use display. That's fine. \n. Let's go ahead and run this and see how it works. Enter a value of x. Let's say I enter 45. Then it's going to, it's not right. While x is less, oh, because 45 is always less than 100. So this is a case of when it will get stuck for infinite amount of time in the while loop. While x is less than 100, y is equal to x squared. Okay, I think this is the problem here. Let me see. X is equal to x plus 1. So I put 45. So x is less than 100. It should do y is equal to x squared. Print it, increase the value of x, run it again. So let's try it again. Okay, let's say 45 again. All right, so it was I think it should be x plus equal 1 instead of x equal plus 1. So it basically calculated the values of y for 45, 46, 47 all the way until it got x. The value got, you can check what is the final value of x, which was 100. So 99 was the last value for which y was calculated, 9,801. So that's the while loop. That is, as long as the condition is true, the while loop is going to run. As soon as the condition is going to become false, the while loop is going to end. And I was showing you this, so I'm assuming, let's try that. There was an error here. Let's see, x plus equal 1. Instead of writing x is equal to x plus 1, we can also, most likely we will be able to write it as well as many programming language. You can do the same. Let's say you have 78. Yep. So you can do x plus equal 1. Or if you, whatever increment that you want, let's say you want to increase it by 5 value of x is equal to x plus 7. Then you can also write that as x plus equal 7. So a short form of the same code. Doesn't really matter. I usually don't remember that. I always remember x is equal to x plus whatever. So update the value of x. So that's the while loop. That's how you use it. Again, you can also use a range. For example, if x is less than 100 or x is greater than 0 and x is less than 100. So you can put a range. X is greater than 0 and x is less than 100. Then the while loop is going to be valid. If it is outside that range, then the while loop is going to give you a false value here because one of them, one or both of them may be 0. And as soon as while loop is going to encounter a 0 value, then it is going to come out of that. So you can use Boolean function between the two values or three values. And as long as you're using the correct Boolean function based upon your requirement, either and or, then you will have one of the conditions from those Boolean functions that is going to be either 0 or 1. So either while loop will keep on running if it is 1, or while loop is going to come out if it is 0. So that is what the while loop is. One of the examples are given here. I'm not going over the example. You can look at it and do it. It's very important. Do the examples again, guys. Don't just read the example. Many of the exercises that you're doing, you can do them correctly if you just do the examples first. Unfortunately, some of the students don't do examples. They just read examples, or some of them don't even read them. Random number generation. If you remember LabVIEW, we had some random number functions. The dice from 0 to 1, you're using uniform distribution. Then you have random range generator in LabVIEW. Similarly, in MATLAB, you have at least 3 functions to generate random number. And these 3 functions are RA and D, rand. As you can see, rand always generates a random number between 0 and 1. And these random numbers are distributed uniformly between 0 and 1. So distribution of these numbers have the equal probability. That's the uniform distribution between 0 and 1. If you want to change the range, go from 10 to 1, then you do the same thing as you did in LabVIEW. That is, you can multiply that by 10. And then your higher limit is going to become 10. It's going to go between 10 to 0. If you want, you can generate more numbers. For example, if you have 4, then it's going to generate a 4 by 4 matrix of random numbers from 0 to 10. You can do 4, 1. It's going to generate 4 rows and 1 column, random numbers from 0 to 10. If you're using rand function and you only want integers, not the decimal numbers, you can use round. Round. Yep. I put insert rand times. So now each number is going to be an integer between 0 and 10 instead of decimal numbers, because I'm rounding off each decimal number. So you can use round, you can use ceil function if you want the integer to be the next integer, not the previous one. Round, of course, is going to round off to the closest integer, whether the previous integer or the next integer. Round is going to do, ceil is going to do only the next integer, and floor is going to do only the previous integer. So if you want to do from 0 to 9, then you can do floor. And it's always going to give you the previous integer. Unless it's exactly 10, your random number, then of course it's going to show you 10. But even if it is 9.99, whatever, it's going to go and floor it down to 9 instead of making it 10 if you're using floor command. So that's the first random number function, RA and D, simply. The second function is RA and DI, which is going to give you a random integer up to whatever number you are putting in parentheses. That is 10. So from 1 to 10. I don't think it gives 0 to 10. I think it gives 1 to 10. Let's see. Help rand I. And I max. Yeah, 1 to I max. So it goes from 1 to whatever maximum value you're using in the parentheses. So if you want only integers, you can just use rand I function to generate random integers. Distribution, what distribution it is using, could be using uniform. I don't know if it is given or not. I don't see it is given, but I don't know which distribution it is using. I'm assuming it's using uniform distribution. The last one is rand n, as you can see over here, rand n. And that's a very important function actually in engineering. Rand n picks up a random number from the normal distribution or Gaussian distribution. Anyone familiar with the normal? I'm pretty sure, Simon, you might be because you're a math guy. And maybe Robert, you may know normal Gaussian. So many of you have seen the bell-shaped curve. of distribution of numbers. This is the normal or Gaussian distribution. And this is perhaps one of the most commonly occurring distribution of numbers in practice. Gaussian, not Gaussians, Gaussian. Most of the distribution, let's say for grades for calculus 2 class or something, most of the distribution follow Gaussian distribution. The middle part is the average value. So let's say C is going to be, let's say, average grade in a class. That's going to be right in the center. Then you're going to have A and B on the lower side of the curve, and then, of course, D and F on the higher side of the curve. Many of you might have heard about Gaussian noise or white noise. White noise, the hissing noise, again, many of you are familiar with the hissing noise. That white noise distribution is also normal distribution. And that function, RA and DN, you're going to be using in signal processing. And, well, at least signal processing, because I have, I think, a couple of labs, a couple of projects in signal processing where you use white noise. But you're going to be using rand n function in signal processing when you're doing some projects in MATLAB, and you will be generating white noise vector and then adding that white noise vector to a clean signal, distorting the signal, and then doing the filtration of the signal and all those things. So rand n is a random number generation from a uniformly distributed data set. So these are the three functions that are very commonly used in MATLAB: rand, rand n, and rand I. Based upon your situation, you can use one of these random number generator. All right, this is one of the exercises that you have to do next week. Generate a random number between 1 and 10. Ask the user to guess the number. If the user guess is incorrect, ask to guess again until user gets it correct. At this point, tell the user that he guessed the number correctly and print out the number of attempts it took for the correct guess. So these are the sample outputs. And again, I saw one of the things while grading the homework. Someone printed my sample output as the output of their program. I'm like, no, this is just to show you that you can get that output from this program. That's not the output, permanent output of the program. So I don't know why that student just printed out the sample output from, because this program was working, but he was not printing out the output from his program. What he was getting, he was just printing out the sample output that was given. So please be careful, follow the requirement of the program, not just the sample output. So these are just two samples from the program that you will be writing, and I'm running my program. So I guess number 5, it was incorrect. It asked me again to guess it again, guess 2, and then 2 was correct. So it just printed out that you guessed it correctly in 2 attempts. And likewise, I ran the program again, went through a bunch of numbers, and finally 7 was the correct number that was randomly generated. So I correctly guessed it in 10 attempts. So this is what you're doing. Again, hint, you have to use what? You have to use while loop. You generate a random number, then check in the while loop if the number generated, well, ask the user to guess the number, then check in the while loop if the number generated is equal to the user's guess. If it is not, ask the user to guess it again. And then keep running the while loop as long as user is guessing the incorrect number. As soon as the user's guess become equal to the number that you generated randomly, the while loop statement is going to become false and it's going to come out. So the statement that you have to make is, if they are not equal, then keep running the while loop. So as soon as they're going to become equal, the statement is going to become false and it's going to come out of the while loop. As far as how you can determine the number of attempts, for that, using while loop, you have to use a counter. And for example, if in this while loop, if I create a counter and initialize that counter with a value, let's say based upon if your first If your first turn is outside the while loop, then your counter will start at 1. If your first turn is inside the while loop, then your counter will start at 0. So let's say in here, I'm not doing any calculation, or I'm not performing any comparison calculation outside the while loop. So I'm going to start my counter at 0. And then here, I'm going to do counter oops. Counter is equal to, well, let's get the wrong line. Why? Counter equals to counter plus 1. So I'm updating the counter. As you can see, page down, insert. So every time the while loop is going to run, it's going to update the value of counter starting from 0 outside the while loop. So first time while loop is going to run is going to be 1, second time is going to be 2, 3, 4. And that you can print to show that. Let's go. That you can print to show that how many times while loop was executed. So in this case, while loop is executed 4 times, right? No. What was my x value? Oh, okay, yeah. The while loop equation is if x is greater than 0 and x is less than 100. Wait a minute. Oh, x is equal to x plus 7. I changed the equation. I thought it's still x is equal to x plus 1, but it's x plus 7. Okay. So with x plus 7, 78 plus 7, 85, and then 7, of course. So it only ran 4 times before the value, before the condition becomes false for while loop. And then it came out of the while loop. So the while loop ran only for 4 times. So the same thing you can apply in this problem, because you have to keep track of how many times did it take for the user to guess the correct number. So inside the while loop, make sure you initialize the counter outside the while loop and then update the counter inside the while loop. Just be careful that you initialize the value of the counter outside the while loop correctly. Either it's 1 or 0 based upon if your first attempt is outside the while loop or inside the while loop. If it is outside the while loop, that will be counted as an attempt, and the counter should start at 1. If your first attempt to guess the number that is inside the while loop, then you're going to start the counter outside the while loop at 0, because you have not even guessed the number once. So based upon your logic, you're going to do the counter properly and then run your program, and make sure the number of turns it is taking you to guess the number is the same as it is printing, as that it took this many turns to guess the program, guess the number. Because that's again a common mistake that I've seen. Many times students, initial value of the counter is incorrect, and many times they are 1 short of the total number of turns it took the user to guess the number. Like for example, if user took 7, they show 6 turns because their initial value was incorrect. So keep that in mind and make sure if it is incorrect, then change the initial value. And again, the change the initial, how do you know what should be the initial value? As I said, if your first attempt is outside the while loop, counter should start at 1. And if your first attempt is inside the while loop, counter should start at 0 outside the while loop. Counter initialization always happens outside the while loop. Update happens inside the while loop. So that's exercise 19 that you have to do. For loops, you guys again did for loops in LabVIEW, and we discussed for loops. Donald mentioned that for loops, you have to run it for a specific number of times. In MATLAB, some students, when I was again checking exercise homework 2, then they were using for loop, for example, for different things. We did not discuss for loop again at that time. The whole idea was to use vectors. And that's, again, one of the beauty of MATLAB is it makes the vector analysis so easy that in many languages, what you have to do with for loops, MATLAB, you can just do it with vectors, which is much easier to do as compared to other programming languages. So for loops, this is the syntax. You have to define the value of k, which is the index for the for loop or counter for the for loop. It starts at an initial value, an interval, and end value. So it starts at the initial value, go through the interval, and then ends at the end value. And then whatever you have to repeat that many times, those operation and statements are in the body of the for loop. A simple example that you have to write a for loop to print a column of real number from 1.5 to 3.1 in the steps of 0.2. So I started the for loop 1.5, increment 0.2, end value 3.1, and then I printed all those values of k using fprintf statement. And this is the output of this program. Okay, in this case, you're asking user to enter a vector, you're examining each value of the vector one by one, and then their condition, if the value is greater than 10, evaluate this expression. If the element is less than or equal to 10, evaluate this expression. And make sure to keep y as the vector that will keep all the values, evaluated values. So what we are doing over here is, let me just, instead of going over that, let me show you what we are doing here. So in this program, or in the program that I can create similar program, I can delete this. Basically, what we are doing here is we are examining each value of a vector. So x is equal to input, enter a vector x to evaluate y. All right, now n is equal to length of the vector x. So we want to know how long the vector, what is the length of the vector, because we want to go through each value of x. And based on the value of x, we will evaluate different expressions for y. And if we do for n is equal to 1 to n, we are running the for loop with a variable lowercase n from the first index to the last index. If x of n, let's say, is greater than 0, then y of n is 2x of n squared. Else if x of n should make a condition here greater than 0 and x of n is less than or equal to 20. So let's say I put two conditions here. I think I can just use, or I can just use in parentheses to separate them. So the first condition I'm putting is if x is between 0 and 20, excluding 0, including 20, then create a vector y, and we can initialize the vector y, and we can initialize vector y outside the for loop. Y is equal to 0, so it will make a vector y with all values to be 0. And then we're going to update the values of y inside the vector. So y of n, perhaps it may give me an error. If it gives me an error, then I can create a vector and assign all values to 0 initially. So y of n is equal to 2x squared, 2x of n squared. Else if x of n, let's say, is greater than 20 and x of n is less than 40, then should do y of n equals 3 times x cubed, let's say. Else y of n equals whatever the value of x is. And if is not really a good statement, to be very honest, because MATLAB does not accept and if. MATLAB just accepts and. Although again, else if MATLAB does not. Else if is a valid expression, but and if is not a valid expression in MATLAB. In Octave, it use and if. It doesn't matter. You can use it because I'm grading your work in Octave. But I prefer if you use just end statement. And. So this is a small program to show how we are using for loop to go through each index, each value that is sitting in a vector x given by the user. And based on the value of the value that is sitting at each index, we decide if we have to calculate another equation y according to the three equations that I put: 2x squared, 3x cubed. That should be 3x of n cubed because it's a specific x of n is a specific value sitting at the nth index, and this will be x of n. So this is an example of for loop. Now observe, of course, since we are going through each index, I don't really have to put 1, 1, n. If you do it, it's fine. But if the increment is 1, you don't really need to put that increment in the for. Like, when we were defining vectors, if the increment is 1, you don't really need to put the increment. But if the increment is not 1, it's 0.1, 0.25, 0.556, whatever, then you have to put the increment. So if I run this program and then give a vector, let's say 120, 34, 55, negative 12, 78, 11, and 25. Let's say this is my vector. And when I evaluated this vector, it went and it checked the first value, y is equal to 120. I guess why it is printing that value. Let me see. Oh, it's printing this value. It's printing this value, sorry. So let's do this. All right, you know what I can do? I can, let's do this. Let's just print the vector outside. Display y. You should put clear statement as well, because whenever you're dealing with vectors, if you already have a vector sitting in the memory, then it can create problems with a new vector if the length is different. So it's always wise to put a clear statement at the beginning of the program when you're dealing with vectors and matrices. All right, in any case, negative 12, 13, 29, 50, 100. Let's see if I have this. Then when the program executed, the first value was negative 12, which falls outside the range what we have defined. Therefore, y is x. Therefore, the first value of y is negative 12. The second value is 13, which falls between 0 and 20. So it's going to be 2 times 13 squared. And the answer is 338. And likewise, the third value is 29, which falls within the range of 20 and 40. So it's going to be 3 times that value cube. And the answer is 73,167. Then 50 and 100 fall outside the range. Therefore, else statement is going to run, and yn will be equal to xn. That's why y is equal to x for 50 and y is equal to x for 100 as well. So this program is an example of for, as well as we are also using if else condition, of course, but basically for that we are using in here. And this is similar to what I'm doing over here. Okay, exercise 20 is again one of the exercises that you did in LabVIEW, in which you have to print a multiplication table of any number. So you're asking user to enter a number for which the multiplication table is going to be printed. And then you're asking user up to which number the table should be generated. So as you can see, enter the number for which you want to create the multiplication table. I put 91. Enter the number up to which multiplication table is required. I put 5. So it printed out the multiplication table from 91 times 191 to all the way 91 times 5 is equal to 455. Again, this is for loop. You're running the for loop for the number of times the multiplication table is required, and then simply multiplying the number that user is giving to produce a multiplication table by the variable of the for loop, because it is changing, starting from 1 all the way up to the number up to which the multiplication table is required. And then you're going to just use fprintf to print out the table. A simple exercise. Work on exercise 11 again using for loops. Okay, what was exercise 11? Exercise 11 was the control system, second order control system, for which you have to create plots. Plotting. Right here, okay. So these plot exercise 11. Now, what I ask you to do in this one is, since we did not discuss for loop up to this point, what I asked you to do was just create 5 equations, different equation, y1, y2, y3, y4, y5, one for each value of zeta, and then calculate the values for each equation and then plot all of them together using plot x, y1, x, y2, and so on and so forth. And the resultant was this. Now, in this exercise, which is, you have to redo this exercise. In this exercise, I'm asking you to use for loop. Now, there was one student who did use for loop, or a couple of students, and I basically put the comment that for loop was not discussed at this time, you should not use it. But the way I'm asking you to use the for loop is a little different than what those students used actually. The way I'm asking you to use for loop is, first you are going to be creating a matrix y1, y2, y3, y4, y5 that you created here. But you don't have to define the equation 5 times. You're going to only be defining equation once, but that one time that you're defining the equation is going to create a matrix. Each row of the matrix will correspond to one value of one series of y for different values of zeta. So for the first row, y is going to be calculated for the first value of zeta, 0.1, second row for second value, and so on and so forth. And once you have that matrix, then you can print that matrix out against x, and you will have this graph. That's the whole idea here. I'll give you an example of what I'm talking about. So let's say you have, let me take my pencil. Okay, so let's say you have an equation f of a comma x, which is equal to 2 times cosine ax. And you have different values of a, and then you have one x vector over which each of this equation is calculated. So you can create, let's say if a value, you're saying a vector is 2 and 5. Then you have two equations, 2 cosine 2x and 2 cosine 5x. And let's say you want to print both of them, like you're printing 5. One way to do it, of course, is the way that you did it this exercise, that you create F1 and F2, and F1 is 2 cosine A of 1x, and F2 is 2 cosine A of 2x. Multiply, of course, multiply some. And then you print out x comma F1 and x comma F2 on the same plot. But the other way to do it is you create a 2-row matrix where the first row is going to be F1 and the second row is going to be F2. And observe, actually not this. This should be just F actually, because it's a matrix variable. So you create a matrix F such that the first row of that matrix is F1 and second is F2. And then you can just print out plot x comma F. And then it's going to print both of them on the same plot. That's the whole idea here. The question is how you can create a matrix easily such that the first row is going to be F1, this, and the second is F2. And then if you have F3, F4, then how you can do that in MATLAB easily. So let me show you how you do that in MATLAB easily. Let me clear everything. So let's say A is 2, 3, 5, 4, 8. Let's say I just take 4 values. And now I'm going to do, let's say I ask user to enter X. Here I'm just going to enter X myself. Let's say my X, the X axis is 0 to, it's a cosine function. So let's say pi by 100 and 3 pi. Let's say this is my X. So if I want to create a matrix such that the first row is going to be F1, which will be 2 cosine A1 times X, so 2 cosine 2X. Second row is going to be 2 cosine 3X, then 2 cosine 4X, and then 2 cosine 8X, and X value is this. I can do for K is equal to 1 to the length of A. For K is equal to 1 to the length of A. So I'm going through each element of A. And then in there, I'm going to do F kth row and all columns. Kth row is starting from 1 and all columns equals 2 times cosine of A of K times X. I should write this down and then you know what? I'm just going to write this down in an editor, so it's going to be easier to change. Let's go ahead and so F K comma colon. K, of course, is the row index. Colon means all columns. Remember, whenever we use colon for any matrix, wherever for the row or column, it means all rows or all columns. So since we don't know what is the length of X, we're just calculating the equation. We say whatever the number of columns are, calculate for all of those columns this equation. then end, and then that's about it. Plot x comma. So what this program is going to do, or what this syntax is going to do, observe I'm not writing f multiple times, the equation multiple times. I'm writing only once, but I'm creating a matrix of f. As I mentioned, where the first row is going to be 2 cosine 2x, the second row will be 2 cosine 3x, then 2 cosine 4x, and 2 cosine 8x. So those are my 4 rows because I'm running the for loop from 1 to the length of a, which is 4. And then I'm putting here a of k. So whatever the k value is, 1, 2, 3, 4, a of 1, a of 2, a of 3, and a of 4 is going to be pulled from the vector a multiplied by x. So if I run this program, let's say if I also clear a statement over here to clear this, clear CLC. If I run this program, I did not save it, but let's save it. Oh, it did not save. Oh, let me. And also observe, what did it do? It printed out, hard to see, but it printed out 4 different waveforms. And well, you see the blue color, you see the purple color, you see the orange color, and you see the red color. So it printed out 4 different waveforms for 4 different functions, or 4 different cosine waveform with different frequencies. So you have a frequency of 2 radian per second, 3 radian per second, 4 radian per second, and 8 radian per second. The higher the frequency, of course, you will have more cycles. The lower the frequency, you will have less number of cycles. So this is how you can create a matrix. So if I show you size of f, so we have 4 rows and 301 columns. 301 column correspond to the length of this vector x. So that's the idea. The idea is to use for loop to create a matrix for this function right here, such that the first row is going to be y of 1, second row will be y of 2, then y of 3, y of 4, and then y of 5, corresponding to these 5 values of z. And once you have that, then you can just go ahead and plot it. You don't really have to do x comma f1, x comma f2. Just x comma f, and it's going to take x, and then each row one by one, and it's going to plot all of them. So that's the idea in that specific exercise that is right over here. And that's how I want you to do this exercise, basically, so that you understand how to create a matrix from an equation with different values using the for loop. So that's right here. So this is what it is about, this exercise. Define the values of zeta in a vector, use for loop to cycle through the values of zeta, zeta of k, save the output y as a row vector each time. Each time the loop is going to run from y of k comma colon, where k goes from 1 to 5. Resultant y will be matrix with 5 rows and n column, where n is the length of vector x that represent x-axis. Make sure to ask the user to enter vector x for which y values are calculated and plotted. So that's what you're doing in this exercise, and that's how you're going to do it to create y of k comma colon with 5 rows, and the number of columns depend upon the vector x that user is entering. Remember, is the user, you have to ask user to enter that. You're not entering it yourself. So that's exercise 21, which is a repeat of exercise 11 in a different way. The next topic is nested for loops. Nested for loops are basically for loop inside a for loop. For loop inside a for loop. And that generally is used when you are cycling through matrix and you are trying to evaluate each row and each column. So you have 2 indices, one for row, one for column. So when you use a for loop for the row and for loop for the column, it's going to be a for loop inside a for loop, something like this. For j is equal to 1 through size of a1, for k is equal to size of a2. So size of a is the size of matrix A, which will be number of rows, comma number of columns. And then I'm running J through the rows of matrix A, and I'm running K through the columns of matrix A. And then I'm examining each value. If A of JK is greater than 50, then do this. If it is not greater than 50, then do this. So I'm creating another matrix, same size as A, based upon the conditions of A. So that's called nested for loop, that is loop inside a loop. First, the inner loop runs, and then the outer loop runs when you're creating a nested for. I wonder if exercise 22 is one of the exercises. Usually I don't give this exercise. Let me check. Exercise 22. 19, 20, 21, 23. Yeah, exercise 22 is not one of your exercises for the homework, but this exercise is pretty much same as this example for the nested for loops. Well, it's not part of your homework. So work on it, but don't submit it. And then the final topic is the series summation, which is again very important engineering concept. As a series is given to you that you have to add and. So for example, this summation, this is a summation sign in MATLAB. There are two signs that are used. This is the summation sign. N is equal to 0 to 10 means it's gonna, whatever the variable n is, it's gonna run from 0 to 10, and you have to sum all the values. And then there is a product sign as well, which is this pi, uppercase pi. And that depends, as whatever equation is written after the product, that's gonna be multiplied. Each product is going to be multiplied by each other for the value from n is equal to 0 to n is equal to 10. Right now, the summation sign is given to us. So this is equal to, starting k is equal to 1 to 10. So it's going to be 1 times cosine of 1x plus 2 times cosine of 2x plus 3 times cosine of 3x. And this goes all the way to 10 cosine of 10x. So this is the series summation. And mathematically, this is how you describe it. And again, this series summation is very frequent in engineering. In electrical, you use Fourier series, you use Laplace transform, you use Z transform, not Laplace, sorry, Z transform, Fourier series. Those all depend on summation of different series. So it's a very common thing in electrical engineering, computer engineering, as to sum up a series of numbers or series of equations. Now, for loop can be used to do this as well. And an example is given right here, that you have to implement a program to do the series summation for this. X is the input over which you are summing all the series. So X is, I'm asking user to enter the value of X, the row vector. And then outside the for loop, first I'm going to initialize the value of this variable, which will be holding the result of the series. So I initialized f of x is equal to 0. That's my initialization of the variable that will be holding the value right over here. This is the initial value of the summation series. And then I ran the series 10 times from k is equal to 1 to 10. So from k is equal to 1 to 10. And then each time I run the series, I calculated the value of this k times cosine of kx, k times cosine of kx. And then I added this value to the previous value of fx. So fx is equal to fx plus k times cosine of kx. So by the time this for loop is going to end, fx will be holding this complete sequence. How? So we start with the first value of k1. It's going to be 1 times cosine of 1x. That will be calculated, added into fx. The initial value of fx was 0. So basically 0 will be added into that and assigned back to fx. So fx value is going to be updated with the first series. Now the k value is going to become 2 when it's going to run again. Fx was holding the first element, and then now you have 2 value of k, so it's going to be 2 times cosine of 2x. So the first value and the second value of the series are added together and assigned back to the variable fx. So now the fx is holding the first two values, the sum of the first two values. Then k value become 3 when it will run the third time. Fx is holding the first two values, and then the third value is going to be added into the first two, and the result is assigned back to the fx. So the first three values are now added together. So this sequence will keep on going until it will hit the last value and then assigned back to fx. At that time, fx will be holding the result of the whole series from k is equal to 1 to k is equal to 10. And then I'm plotting basically x versus fx. And the plot looks like this. So this is the last thing in the last exercises. Calculate and plot the following summation series over x. Ask the user to enter the value of zeta as a vector and values of x over which the summation series will be evaluated and plotted, which is also a vector. So you're going to ask user two things here. You're going to ask user to enter the value of zeta over which these sequence is going to be plotted. So let's say zeta is equal to 0.5, 0.6, and 0.9, three values. And then you're going to ask user to enter the value of x, which is the x-axis over which this will be evaluated and plotted. And once you have that, then you're going to go ahead and run this over each value of zeta. Observe zeta k. Zeta k means what? Here, k is equal to 1, 2, and 3 because the value, the length of zeta is 3. So n is the length of the zeta vector. So n is the length of the zeta vector. So n is equal to 3 in this case. So k is running from 1 to 3. So when k is going to be 1, you're going to have 1 minus 1 over square root of 1 minus zeta of k. Zeta of k is going to be zeta of 1, which will be 0.5 square e to the power negative zeta of k, which is again zeta of 1, which is 0.5. And so wherever you have the zeta k, that's going to be zeta and the index of the zeta vector. So whatever value sitting at that time, at that index, that value is going to be picked up and replaced by zeta of k. Now, some students make a mistake. They do zeta times k. This is not zeta times k, remember. Zeta is a vector. K is the index of that vector. So that's zeta of k means that the value that is sitting at the kth index of the zeta vector, that value is going to be substituted for zeta of k. So don't do this thing, because I've seen some students do this, and then of course everything is incorrect in their result. So similar to the last example, you are going to do this. Run it for the number of times. You have z. So you can check the length of z basically initially, and that is going to be your n for which you're running this loop from k is equal to length of z. And then perform the same thing like we did in this example. And at the end, you're going to plot that and see how the plot is going to be. There's going to be single plot, remember, it's not multiple plots because you're adding all of the series. So it's going to be a single plot for this, like you have a single plot here. It's not 5 plots like you had or 6 plots like you had earlier in exercise 11 or other exercises. The equation is the same second order equation, but now you're adding all of them together and then printing only one plot. And that concludes the MATLAB portion of this chapter as well. If you have any questions, I will be happy to answer your question about MATLAB, what we had today, or anything else.
I can see why they mess up the k right there, because it looks like you're doing k squared on that first right there in that first one you did.
Well, it's zeta of k squared. So again, zeta of k
Yeah.
is zeta, and the k is the index. So we're taking the square of that element. Yeah, I can put this in parentheses, zeta of
Yeah. You just got to know you're calling the index because
square.
I can see where I'm going to forget this later on when I'm doing the homework and do that.
Just be careful. This is a mistake. It's not zeta times k again, or it's not zeta of k square. It's zeta of k is zeta vector, k is the index, and then you're taking the square of that value. So 0.5 is square, 0.6 is square, 0.9 is square. That's what you're doing. So be careful about this, please. This is a mistake. Yeah, some students make that mistake. All right, guys, that is about it. Everyone is in the class, so everyone is present. And if you have any question, I'll be happy to answer your question. If not, then we are done for this semester. Good luck with your exam. If you have not taken the student feedback on instruction survey, and please do so. It's a couple of days left before it closes down. So take that survey. That's important for me. And for every class of yours, whatever classes you're taking, take that survey, student feedback on instruction. I'm going to stop recording and